Today, we're diving into an absolutely incredible design challenge that's happening inside your own throat. We're calling it the body's unlikely neighbors. And it's really a tale of two tubes working side by side in perfect and pretty critical harmony. So let's explore how they pull it off.
I mean, just think about it for a second. Every single time you breathe, every time you swallow, you're counting on this invisible traffic control system to prevent total chaos. So how does your body manage to send air down one path and food down another when their front doors are literally right next to each other? Well, here they are, our two main characters. You've got the trachea, which is the airway to your lungs, and it's sitting right there in front of its neighbor, the esophagus, which is the food path to your stomach. You couldn't get them any closer, but their jobs couldn't be more different. So let's get properly introduced to these inner neighbors. You can think of them as two of the most vital highways in your body, and their flawless cooperation is essential for, keeping you alive. And right away, you can see how they're basically polar opposites in their design. On the left, the trachea, your windpipe, it's built for air, it has to be open all the time, and it has a really rigid structure. Then you have the esophagus, the food chute, and it's the complete opposite. It's for food, it's normally closed shut, and it's muscular and flexible. Two totally different design philosophies for two tubes that are practically roommates. Okay, let's start with the trachea. Probably the best way to picture it is as your body's own reinforced air hose. Its only job is to provide a clear, totally unobstructed path for air. So how does it stay open? Well, the trachea's big secret is its support system, about 15 to 20 C-shaped rings made of cartilage. Now, they're not full circles, they're shaped just like the letter C, and this gives the tube just enough rigidity to stay propped open permanently, so you can breathe without ever having to think about it. And this helps you see the bigger picture. The trachea is like the main trunk. It's the superhighway for all the air coming into your respiratory system. But of course, the journey doesn't stop there. That air needs to get way down deep into the lungs to be of any use. And here's how it gets there. The trachea splits into two main branches, the primary bronchi, one for each lung. Then, those branches split into secondary bronchi, and they just keep dividing again and again into smaller and smaller tubes called bronchioles, almost like the branches of a tree. And that whole journey finally ends in millions of tiny little air sacs. And the scale here is just staggering. We're talking about 300 to 400 million of these tiny air sacs called alveoli inside each of your lungs. This is where the real magic happens, where oxygen finally gets into your blood and carbon dioxide gets out. And it all starts with that one single windpipe. All right, now let's turn to its neighbor, the esophagus. If the trachea is a reinforced air hose, the esophagus is way more like a smart, muscular conveyor belt. See, its job isn't just to be some passive tube. Oh no, it has to actively move things along. It's about 25 centimeters long, and you can immediately see the difference. Unlike that rigid trachea, this is a collapsible, muscular tube. It doesn't just rely on gravity. It actually grabs onto the food you swallow and physically pushes it down toward the stomach. And that active pushing action has a name. It's called peristalsis. It's this beautiful, coordinated wave of muscle contractions that travels all the way down the esophagus, making sure your food gets to your stomach, whether you're standing up, lying down, or even if you were upside down. It's a one-way street, and it's enforced by pure muscle power. Which, of course, brings us right back to our central question. With these two completely different tubes living side by side, how on earth does your body master traffic control and prevent a total mix-up of air and food? Well, the answer comes down to two critical gatekeepers, the esophageal sphincters. You can just think of them as muscular valves. The upper one stays clamped shut most of the time to keep you from swallowing air with every single breath, and the lower one, it acts as a crucial one-way valve to stop powerful, corrosive stomach acid from splashing back up. And this quote really nails why that lower valve is so important. When you're not eating, its main job is just protection. Specifically, as it says here, preventing the reflux of all that acid from your stomach. It's a simple function, but it has massive consequences if it ever fails. So what happens when this elegant system breaks down? Well, the fallout isn't just some anatomical curiosity. It has very real clinical relevance, and it can range from a common discomfort to some really serious health risks. Let's ask the question directly then. What is the chain reaction that gets kicked off when that lower esophageal sphincter, that little valve between the esophagus and the stomach, stops doing its job properly?
Well, the very first domino to fall is chronic irritation. A faulty valve lets stomach acid splash back up, or reflux, into the esophagus. The thing is, the lining of the esophagus just isn't built to handle that kind of acid, so it gets irritated and inflamed, causing that all too familiar burning sensation we call heartburn or indigestion.
Now, if that acid assault keeps happening over a long period of time, the body does something pretty surprising to try and protect itself. The cells lining that lower part of the esophagus actually start to change. This process is called metaplasia. They basically transform into a more acid-resistant type of cell, kind of like the ones you'd find in the stomach. And this condition has a name, Barrett's esophagus.
And here's why this is so critically important. Even though this cell change is meant to be a protective measure, it's also unstable. These new transformed cells are actually more likely to become cancerous. Specifically, Barrett's esophagus is a known precursor to adenocarcinoma, a type of cancer that pops up exactly where all the damage is happening, in the lower third of the esophagus. So you see how a simple mechanical failure of a tiny valve can, over time, lead to cancer.
So what we've seen is this incredible silent partnership happening in your throat with every single breath and every single bite. The trachea and esophagus, two unlikely neighbors performing their wildly different jobs in perfect harmony. Which just leaves us with a final thought to ponder. What other invisible, intricate systems are flawlessly running your body right at this very moment?